Hello, welcome back to the lecture series on Transport Layer Protocol of the Internet Model. In this video, we are going to learn about UDP Overview Part 2. So what is the agenda? We are going to learn about UDP encapsulation and decapsulation. After that, queuing in UDP, followed by uses of UDP. UDP encapsulation and decapsulation. Encapsulation means data moves from upper layer to the lower layer. Actually, UDP data gets encapsulated in IP datagram. On the other hand, decapsulation means data moves from the lower layer to the upper layers. So it is decapsulated from the IP datagram. Let us look at encapsulation and decapsulation with the help of this diagram. Let's say we have the application layer here and message from the application layer process. Let's say this is the sending end and this is the receiving end. Data from the application layer moves to the transport layer. The transport layer treats the data from the application layer as the data and includes a header. This entire transport layer data is fed to the network layer as data along with the header of the transport layer, and at the network layer again one IP header is inserted. Now, data from the network layer moves to the data link layer and it includes a header as well as a trailer. This then moves to the physical layer, which converts the data into bit streams and ultimately to signals. And this signal then moves to the transmission medium through the internet. At the receiving end, so this is about encapsulation. At the receiving end, we have decapsulation. So data at the physical layer as received from the transmission media is moved to the data link layer, and the corresponding header and the trailer are removed and fed to the network layer. At the network layer, again the IP header is removed and fed to the transport layer, and from the transport layer it moves to the application layer. So this is about encapsulation and decapsulation of UDP data into the IP datagram. Let's understand queuing. Queuing is a process when somebody wants to communicate is given only one port number, one outgoing queue, and one incoming queue. So three things are necessary for the transport layer to transmit data through the port. We have understood about port in earlier videos, but we have never gone into the details of queuing. So let's understand queuing with the help of this pictorial representation. Let us consider a daytime client. So this is basically a process which is running at the client end. So there will be two types of queues which are defined by the process upon request. One is the outgoing queue. It is a queue through which data from the application layer moves to the lower layer. And the other one is an incoming queue by which data from the lower layer moves to the application layer. And this queuing is requested from the UDP. Now, there is a port associated with the daytime client, and this port number is 52000. Now, this client may be connected to different servers for different processes, but there is only one outgoing queue and the other one is incoming queue. If large number of requests come in, they must be fed at the end of the queue. Now for a data moving into the queue, if the data finds no queue, then it simply discards the datagram and asks the ICMP protocol to report a destination unreachable message. Similarly, if the queue is getting overflowed, then also the destination unreachable message will be given by the ICMP protocol and the remaining data will be discarded. What happens at the server end? We have a daytime server. Here also there will be one outgoing queue and one incoming queue. So this queue will be defined or allotted to the server upon request from the UDP. A particular port number will be allotted, and in this case it is port number 13. So all the outgoing data will be going through this single outgoing queue and incoming data will be coming through this incoming queue. Similar to the client process, if for any incoming data, if it finds that there is no queue, then the data will be discarded. And then it will ask the ICMP to send destination unreachable message. Similarly, if the queue gets overflowed, then also the destination unreachable message will be given by the ICMP protocol and the particular datagram will be discarded. Now for the client side, the ports that are used will be the ephemeral ports, and at the server side, the ports that are used will be the well-known ports. The different types of ports like well-known ports, registered ports, and ephemeral ports have been discussed in a separate video. Now, what are the uses of UDP? UDP may be used for a simple request-response communication, and it is not suitable to send bulk data that is used for file transfer protocol. Like if you have a client and a server, you can make a simple request and response message, but not to send bulk data over the file transfer protocol. The next use case of UDP is to check for internal flow and error control that possibly is used in TFTP. TFTP is Trivial File Transfer Protocol. The next use is in multicasting. UDP is used for multicasting, unlike TCP. It can be used for various management related process by using the SNMP or Simple Network Management Protocol. It can also be used for updating the routing information using several routing information protocols or RIP. To summarize, in this video, we have learned about the concept of encapsulation and decapsulation of UDP, how UDP datagram is encapsulated inside the IP datagram and decapsulated at the receiving end. The idea of queuing, what are the incoming and outgoing queues, and when will the ICMP protocol return the destination port unreachable message. And we have learned about the various uses of UDP. Thank you.